Suspension system component identification. With any car or light truck on the road today, you will find a variety of suspension systems. For instance, the ride over rough roads is most comfortable when the suspension is soft and compliant. Handling stability, on the other hand, typically improves as suspension stiffness increases. Consequently, the design of any particular suspension system is always a compromise. All suspensions require springs of some kind, motion dampers, and structural members that tie the springs and motion dampers to the vehicle, as well as locate the wheels properly. Springs can be coil springs, leaf springs, air springs, or torsion bars. Coil springs are made up of one piece of spring steel wrapped into a series of cylindrical coils. By varying the distance between adjacent coils, the diameter or the wire thickness can be made progressively harder to compress. Leaf springs consist of flat pieces of steel held together with bands. Because of their heavy-duty nature, they are commonly used on truck suspensions, not only for pickups and sport utility vehicles, but for medium and heavy-duty trucks as well. Air springs actually consist of air chambers or bags filled with compressed air. The bags can be sealed or supplied with varying amounts of air by an onboard air compressor. Newer versions often use a computer-controlled compressor to adjust ride height as vehicle load changes. Torsion bars act like springs, but they consist of a straight length of solid or tubular spring steel with one end firmly fixed. When the other end is rotated about the long axis, the twisting energy is stored, and the steel rod will return to its original state as soon as the twisting force is removed. Motion dampers are typically either conventional shock absorbers or similar piston-type devices mounted integrally within a strut assembly. These dampers contain hydraulic fluid and, in some cases, pressurized nitrogen gas. The springs in a suspension system react to load changes or shocks to the system, absorbing the force so that the vehicle body won't. The spring will store the energy and release it by returning to its original shape and size. In practical application, the spring will continue to oscillate back and forth from a compressed condition to an extended condition if not controlled. A motion damper dampens the oscillating action of the spring. Properly tuned, the motion damper will allow a compressed spring, when released, to extend slightly beyond its natural length or shape, then to return to the original position. As suspensions continue to evolve, new, more dynamic systems and components will drive the technology. Electronic suspension systems that create a smoother ride than a luxury sedan with less roll and pitch than a sports car. Stability and traction devices that help control speed, braking, traction, and attitude of the vehicle. Traditional spring and shock absorber systems will be enhanced as suspension systems become active in supplying safety, comfort, and control.